So, now after Thomson model of atom, now there is a Rutherford's alpha ray scattering experiment, which actually explains about the atom and the discovery of the nucleus. This experiment was performed with the help of the Geiger and Marsden. So, that is also known as Geiger-Marsden experiment. Now, here in this experiment, first it is here the lead cavity is taken, in which source of alpha particle is taken here, which emits alpha particles. Now, there is a collimator. With the help of the collimator, alpha particles are formed taken in the form of the beam, that is called collimated beam, and now after that these alpha particle is made to strike on the gold foil. This gold foil is 10 raised to power minus 8 meter thick, and then there is a screen that is called ZNS screen. In this zinc sulphide screen, whenever the alpha particle strikes, the scintillations are produced, or you can say the flashes are produced. By this way you can get where the alpha particle is striking on the screen. There is a detector which can detect the striking of the alpha particle. It means the scintillation can be here detected with the help of the detector. Now, when this experiment was performed, it was found that most of the alpha particle passing through the straight line without much deviations, and only very few alpha particle, around 0.14% alpha particle were getting scattered more than the angle of 1 degree, and very few alpha particle, around in every 8,000 alpha particle were getting deflected more than the 90-degree angle. So, with the help of these observations, it was concluded that inside atom, most part of the atom is empty, where the alpha particles are passing, like this is one is a straight line here, they are not getting deflected. And as the alpha particle is approaching towards the center of the atom, they are getting deflected by the large angle, scattering angle, and the alpha particle which is striking at the center here, that is getting rebounced back. It means it shows that the center part is very heavy, having positively charged, because alpha particle is also positively charged, that is the 2He4 helium nucleus. So, helium nucleus can only gets rebounced if it is being repelled by the nucleus here. So, the particle which is bouncing back at the large scattering angle, that shows that the center part of the atom is positively charged and it is very heavy, but rest part of the atom is almost empty, there the electrons are found here. So, according to the Rutherford and Coulombic force of repulsion, on the basis of the Coulombic force of repulsion, it was established that the center core of the atom is called nucleus, which is positively charged, and entire mass of the atom is assumed to be concentrated at the center. So, after this, they see here the number of alpha particles scattered and scattering angle. So, this is the actually graphical relation between the number of alpha particle and scattering angle. Here in this, it is shown that here the large number, these dots I have shown here, alpha particles is scattered. So, large number of alpha particle getting scattered at a small angle. As the angle increases, number of alpha particle scattered gets reduced. So, here at 180 degree only one particle which is getting reflected. So, with the help of this experiment, it was the nucleus was discovered, and it was established that entire mass of the atom is concentrated at the center, which is called nucleus and having positive charge.